Good morning, grade 5. Congratulations for finishing your lesson 2 activities. Now we proceed with lesson 3. It's all about divisibility rules. Say it with me. Divisibility rules. 2, 3, 4, 5, and 6. Now here are the following objectives. Determine the rules and divisibility. Use divisibility rules to find common factors of numbers. Solve word problems that involve applying the concept of divisibility. Are you ready? If you are, then let's have fun together. This will serve as a review for last week's lesson. So round off the following numbers. So all you have to do is to write your answer on the right side of the table. Number 1 is 7,655,001. Round it to the nearest millions. So all you have to do is to underline first where the millions is. So it's here, it's the 7, right? So what is the number to its right? It's 6. And 6, is it round up or round down? It's round up. So what happens to 7? We add 1. So 7 plus 1 becomes 8. And then all you have to do is to make all the numbers to its right into 0. So the answer is 8 million. Now I want you to pause this video and do number 2 and number 3. Alright, if you're done with this, then let's proceed with the next slide. Activity 1. Below are 50 pieces of longanisa. Can you share the longanisa equally to 2 friends, 3 friends, or 5 friends? Okay, so I have here 25 longanisa. The question there is, can I share it equally? Okay, so let us underline the word equally. So when we say equally, there needs to have, there should not be any remainder when you divide it. Okay, so if it's only 2 friends, can I divide it equally, the 50? Yes, I can give 25 to the first friend of mine, and I can give another set of 25 pieces longanisa to the second friend of mine. So if it's 25 plus 25 is equal to 50. So both of them were given 25 already. So what should I do? If I can divide it equally, I'll just put a check on the underline. Okay? If I cannot divide it equally, and then we can put an X on the underline. Okay? So just simply put a check or X. If you're done with this activity, then let's proceed with the next slide. Let us discuss. Divisible by means that when you divide one number by another, the result is a whole number. A whole number is divisible by another number if the quotient is a whole number and the remainder is 0. So you always take notice of this one. The remainder is 0, and that is what we call divisible by. What number, let us take this as an example. What number can divide 50 so that the remainder is equal to 0? So we have here a set of numbers, and all of it, when you divide it, the remainder is 0. Okay, so 50. 50 divided by 1 is equal to 50 itself, right? 50 divided by 2, if you make 50 into half, that becomes 25. And the remainder is, again, 0. 50 divided by 5, okay, if you just keep counting using your fingers, it's 5, 10, 15, 20, 25, 30, until 50, you get 10. Okay, 10 of your fingers will show up. And then if you divide 50 divided by 10, using your fingers again, okay, using your fingers, it's 10, 20, 30, 40, 50. So how many fingers show up? 5. Right. Same is true. 50 divided by 25. Okay. The answer is 2. So all of it, the remainder is 0. Therefore, 50 is divisible by 2, 5, 10, and 25. Thus, all these numbers become the factors of 50. Okay? But how do we know that a number is divisible by another number without actually performing the process of division? Right? So that is our lesson for today. It's all about testing whether a number is divisible by a certain number without actually performing the process of division. So there are shortcuts on how to do it. Okay? Let's proceed with the next slide. Divisibility rules. So you have to encircle the numbers that are divisible by 2, 3, 4, 5, or 6. Let us take divisibility test for 2 first. If a number is even or ends in 0, 2, 4, 6, or 8, it is divisible by 2. So it's very easy. If you see that the number is an even number, when we say even numbers, all of the numbers end with 0, 2, 4, 6, and 8. Okay, by simply looking at the last digit of the number, if it's an even number, immediately it is divisible by 2. So I have to encircle it. Let us take 10, for example. 10. Okay, this 10 here. Is it an even number? Yes, because I can find 0 there. Right? So I have to encircle it because it is divisible by 2. Alright. How about, let us take the last number, 21. Okay, 21. Is it an even number? No, because I cannot find 1 here, right? You cannot find it. So I will leave it just like that. Okay, I will not encircle it. All you have to do is to just encircle all the numbers that are divisible by 2. Okay, now we proceed with the divisibility test for 3. If the sum of the digits is divisible by 3, then the number is divisible by 3. So we have here the keyword again, sum. Okay, sum. When we say sum, it's when you add something. Okay, so all we have to do is to add all the digits that are present. If it is divisible by 3, then it's divisible. If the digit is divisible by 3, then the number is divisible by 3. Say, for example, which number below do you want to add? Okay, say 54. Okay, 54. Is 54 divisible by 3? Let us see. All we have to do is to add the digits. So 5 plus 4, because it's 54, right? So 5 plus 4 equals 9. And is 9 divisible by 3? If you do skip counting, okay, and if you do skip counting and you hear the word 9, then it is divisible by 3. No, that's how I do it. I don't know how you do it, but that's how I do it, using skip counting. Okay, let's do skip counting. 3, 6, what comes next? 9. So therefore, 9 is divisible by 3. So I have to encircle 54. Okay? But how about 13? We add all the digits. 1 plus 3 equals how many? 4. Okay, so for you not to be confused, let us erase everything. Okay, 13. 1 plus 3 equals 4. Now the question is 4 divisible by 3? Let us just keep counting. 3, 6. Okay, immediately it went to 6. And I was not able to say the word 4. So, 4 is not divisible by 3. So I will just mark, I will just not touch it. It's just like that. Okay? All you have to do is just encircle all the numbers that are divisible by 3. Again, 54 is divisible by 3. And the rest of it, I want you to answer. Okay? Alright. Now if we're done with this, then let's proceed with the next divisibility test. Divisibility test for 4. If the number's last two digits form a number that is divisible by 4, or the last two digits are zeros, then the number is divisible by 4. So, last two digits form a number that is divisible by 4. Last two digits. Okay, so all we have to do is to underline all the last two digits. Okay, here it's 24, here it's 00, here it's 0. Okay, sorry for that. Okay, so just like that, no? Just the last two digits. So for 124, the last two digits we have 24. Is it divisible by 4? Okay, to make your life easier, let's just do skip counting because that is easier. And if you will be able to say 24 in the skip counting, then it is divisible by 24. But if you are not able to say 24 in the skip counting, then it is not divisible by 4. Okay, let's do it using your fingers. 4, 8, 12, 16, 20, 24. Okay, I was able to say 24. Therefore, it is divisible by 4. So I have to encircle it. Right. And another rule here is that the last two digits are zeros. The last two digits are zeros. Can you find numbers wherein the last two digits are zeros? Right. There are, right? So 500, the last two digits are zeros. Therefore, immediately it is divisible by 4. Okay? So all you have to do is to encircle all the numbers that are divisible by 4. If it is not divisible by 4, just don't touch it. Do not do anything. Okay? Now we go with divisibility test for 5. If a number ends in 0 or 5, it is divisible by 5. It's very easy. All you have to do is to see whether the number ends in 0 or 5. Okay, so can you see numbers here wherein it ends in 0 or 5? If you do, then just encircle that number because that is divisible by 5 already. Okay, that's very easy. Now, let us go with divisibility test for 6. Excuse me. Alright. Divisibility test for 6. If a number is both divisible by 2 and 3, then the number is divisible by 6. So the rule here is that if it is both divisible by 2 and 3, then the number is divisible by 6. Now we go back with the rule for divisibility test for 2 and 3. If a number is even, so you have to take note of this one, even number that is divisible by 2. And here it's the sum, okay, that is divisible by 3. Alright, so let's take a look of 36. Okay, 36. Is it an even number? Yes, it is an even number. So I'll just put a check here on the side. Now, if we add 3 plus 6 equals 9. Is 9 divisible by 3? If you're not sure, you do skip counting. 3, 6, 9. So I was able to mention 9. So therefore, it is also divisible by 3. So I will encircle 36 because they are both divisible by 2 and 3. Therefore, the number is divisible by 6. Now, let us take another example. 123. Is it an even number? The last digit is 3. Is 3 an even number? No, so it's an X. Okay? If it is not divisible by 2 or it is not divisible by 3, then just don't touch the number because that is not divisible by 6. All you have to do is to encircle all the numbers that are divisible by 6. Alright? So, if you're done with this, taking a screenshot of this part of the video, then let's proceed with the next one. Activity 2. Which of the following is divisible by 2? Put a check on the space provided. Okay, so you can see in your module, okay, in the printed learning material, the rule, right? If it's divisible by 2, all you have to do is to put a check. Okay, all you have to do is to put a check. If it's not divisible by 2, then don't check anything. Okay, same is true with letter B, same is true with C, D, and E. Just put a check in the space provided. Alright, if you're done with this, then let us remember the following. A number is divisible by 2 if it is an even number. A number is divisible by 3 if the sum of the digits is a multiple of 3. A number is divisible by 4 if the last 2 digits of the number is divisible by 4. A number is divisible by 5 if its one's digit is 0 or 5. A number is divisible by 6 if it is an even number that is divisible by 3. Alright, I hope you were able to grasp all the information here, so you can challenge yourself. So using one crayon, any crayon that you want, color the table that tests for divisibility by 2, 3, 4, 5, and 6. An example was done for you. So we have here 730. Based from the rule, it's an even number. Okay, 730 is an even number, so I already shaded here 2 because it is divisible by 2. Why did I not shade the 3 here? Why? Because if I add 7 plus 3 plus 0, it's 10. And if I do skip counting, 3, 6, 9, 12, I was not able to mention 10. So I just leave it blank like that. The same is true with 4. It's not divisible by 4. And it is divisible by 5 because it ends in 0. So I was able to shade it. And it's not divisible by 6. Okay? So just like that. So you do the shading with this table. If you have any questions, feel free to ask me in Messenger. If you do not have any questions, so feel free to ask for help from your parents or your older siblings if you have. Alright, God bless, good luck, and keep safe, grade 5.